talk about SPOS, Standard Product of Sums format. Okay, so as we studied in SSOP, the standard sum of products, yeah, the standard product of sums should have all the signals in the domain, all the variables in the domain. Okay, so for example, let's say Q is given as A plus B, okay, A plus B into B bar. Okay, so let's say this is what we have. This is actually in POS form. Okay, this is actually in POS form. Why? We have a sum here, we have a sum here. There is an AND gate that is connecting these two. Okay, but whether is it in SPOS? No, it is not in SPOS. I'll just show you an example so that you will understand what SPOS is. So let's say we have something like F is equals to A plus B, okay, into A plus B bar. This is uh, this is an expression that is in standard POS format. Okay, so let's say we have something like Z that is equals to A plus B plus C into A plus B bar plus C. Okay, so this is also in the standard POS form. Okay, standard product of sums form. But this is not in standard product of sums form. This is in POS, but this is not in SPOS. So what should we do here is, well, I'll just teach you simply. Just look at this. Okay, first of all, look at this distributive example. Okay, so we learn that A plus B, okay, A plus B dot A plus C is equals to A plus BC. Okay, this is distributive law that we have already learned. Okay, let me just ask you something. Okay, let me just ask you something. Let's say we have something like A plus B plus C dot A plus B plus D. How can we rewrite this without expanding everything? How can we rewrite this? Well, if you think of it like this, okay, A plus B as a single signal, okay, we have A plus B plus C and A plus B plus D. So I can write this down as A plus B plus CD. Do you agree with me? Okay, so here we have A, here we have A, so here we have A. Okay, here we have B, here we have C, so the output is B dot C or BC. Okay, similarly, here we have A plus B, okay, here we have A plus B, here we have A plus B, so here we have A plus B. And here we have C, here we have D, so that is given as CD. So this is one of the basic things you have to keep in mind when you are converting from POS to SPOS. This is just one step. This is just one step. There is another step. Okay, there is another step. Do you remember the inverse law? This is distributive law. Okay, so this is distributive law. Okay, do you remember the inverse law? Do you remember the inverse law that we studied when we were learning about the Boolean algebra? Okay, inverse law. Okay, not inversive, inverse law. Inverse law had two applications. One was A plus A bar is equals to 1 and A dot A bar is equals to 0. Do you remember this? Okay, so these two are what we are going to use. Not this one actually. This one and this one. That is what we are going to use. Okay, stay with me. Okay, let's remove this first. Yeah, let's remove this first. So stay with me. Okay, what am I going to do? Here, what I'm going to do is, this B bar cannot be B bar because we have to have A and A bar. I mean, it doesn't have to be A bar, but we have to have A in any format, A or A bar. Okay, so what I'm going to do is, I'm going to rewrite this. A plus B is fine. We don't have to do anything with that. A plus B dot B bar dot 0. Okay, I'm just multiplying it. Sorry, I'm just adding 0, not dot 0 plus 0. I'm not doing anything miraculously. I'm just adding 0. According to the identity law, A plus 0 is equals to A. Okay, just arg it. Now what I'm going to do is, I'm going to replace the 0 with A bar. A dot A bar. Okay, I'm going to replace it with A dot A bar. Can you see where I'm going with this? So I'm using the inverse law here. Step 1 completed. Now we are going to step 2, applying the distributive law. Okay, B bar plus A dot A bar can be given as B bar plus A dot B bar plus A bar. Can you understand? Okay, so this is where we apply the distributive law. Here I'm just applying the identity law. Okay, the basic one. Okay, then I am applying the inverse law. Here I am applying inverse law. Here I am applying the distributive law. I'm applying the distributive law. Actually, now Q is given in standard product of sums format. Standard product of sums format. So let me write this down properly so that you can see that. So here we have A plus B, which is a sum, and then A plus B bar, which is a sum, and then A bar plus B bar, which is another sum, connected by using AND gates. All the sums have all the signals of the domain A and B. Okay, so this is how you can convert POS to SPOS. Okay, you may ask, yeah, this is so immature. Why? In this question, okay, in this question, let's say Q is given as B bar into A plus B. இல்லையா? So what I can do is I can just remove. Yeah, I can just remove these things. So if I remove the brackets, I will get AB bar plus BB bar, and we know BB bar is equals to 0. So Q is equals to AB bar. So that is enough, right? Why do we need to do all this shenanigan? Well, we are not learning about simplification here. No, we are not simplifying anything. We are looking at the expressions in different forms. We learnt about SOP, we learnt about SSOP, we learnt about POS, and now we are learning about SPOS. SPOS is not about simplifying, it's actually the reverse. We are going back to the starting point. Okay, these are very important when we are writing the truth table and all. Okay, so keep that in mind. This is very important.
Thanks for watching 15th video in our Logic Key series. If you found this introduction to SPOS and the techniques for converting POS to SPOS helpful, don't forget to like, share, and subscribe for more lessons. Hit the bell icon to stay updated with the latest videos. I will be releasing another video on SPOS soon, so check out the full playlist to Master Logic Gates. Follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.